Hello, everyone. No presentation today. Instead, we're just going to talk about a useful program called Valgrind. And we're also going to discuss Makefiles and how we can use those to run our programs more easily and just make our life when we're writing C programs a little easier. Okay, so first, Valgrind. So Valgrind is this tool for debugging C programs. It comes with a collection of tools. But the one we're mainly going to be focused on is going to be the memcheck tool. This is going to help us to detect memory leaks. So this is a pretty Googleable tool. You can just look up how to use Valgrind to check memory leaks, and this is going to be the first entry. But it's pretty simple to use. You just call Valgrind with the option tool equals memcheck, leak check equals yes. And this is optional. You can do track origins yes or track origins no. This will give you a much more verbose output to see exactly where you made these errors or exactly where this was allocated and then freed. So right now we have the program, our dictionary program that we made in a previous video. And we're going to run Valgrind on it. Notice that I've commented out the delete call at the end there. So when we run Valgrind on this to detect leak checks, we should expect that we have some leaks. And you can see a leak summary, definitely lost 16 bytes in 1 block, indirectly lost 87 bytes in 8 blocks. Errors, and then it's going to try and track down where you made losses. So malloc in by the dict function, yeah, in main. So a malloc made by the dict function was never freed. Malloc in add word, malloc in indict, add word. Yeah, so you can see this very verbose output. I believe if we take away track origins equals yes, then we'll get a much more simpler, yeah. I guess it's still pretty verbose. But anyways, it can help you detect this leak check. What we should expect to see if we actually delete this, though, is no memchecks. Oh, if we remake the program first. And there we go. So because we properly deleted and freed everything we allocated with our handy dandy delete function, which is defined here. Yeah. We lost 0 bytes in 0 blocks. So we freed everything. Good job. But yeah, so if you are having random crashes and segmentation faults, you should try to use Valgrind. Again, it is installed on Tux. If you're on macOS or Linux, then it should be pretty easy to install. It is not available in Windows. So if you're working on Windows, you're kind of out of luck on this one. But if you're on macOS or Linux, or you are developing on Tux, as everyone should be, then you have access to this tool and you should use it. Okay, so now let's talk a little bit about Makefiles. So Make is another program that should be installed on Linux and macOS, and more importantly, Tux. So Make. So Make is a tool. It basically runs a configuration file that you specify, and it can run commands, and it will check like dependencies. So you basically make a task and dependencies of that task. Okay, so let's look at the basic Makefile I have for Scratch. So it has 2 tasks to run. Scratch is dependent on scratch.c. So if scratch.c has been updated at all, when you call make, it will run this command right here. And this is obviously the command to compile the Scratch program. So it's running my compiler, GCC, with scratch.c and utils.c. Utils.c just contains one other function, but it's not important. If you're not familiar with including multiple files in one compilation, don't worry about it. Just we include the scratch.c program, we give it a name with the -o flag, Scratch, with all warnings, extra and pedantic. So this is configuring like, tell us everything, tell us every little problem that you find. And then specifying the standard as C17. I would recommend using C17, use the newer standards here, because if you use the older ones, you might have trouble with things like malloc. In particular, in older C standards, you had to cast the return value of a malloc call from void to something else. Really annoying. Use the newer standard, it'll be smoother. Okay, so then we have another task, run, which is dependent on the scratch task having been run. So what this will do is it will run the program, scratch, and that's what this is doing, just calling the program in the local directory, and then it's going to remove the executable. So you can actually see currently I have the executable. If I do make run, it's going to run it and it deleted the file. Okay, so if I ever want to run the program, I can just type make run as long as I'm in the current directory of the program. So let me actually go to this in my main terminal. Right, so if I just type make run, I get the output of my program. So if you're on Tux, then you have access to this make program and you should make a Makefile. If you just want to use mine as a template, that's totally fine. Just the name of the program, replace the name of your program with scratch, or replace scratch with the name of your program, sorry. And you can use this exactly. And if you use my template, then you can do make to just create the executable, in which case you can run it yourself with scratch. And if you type make run, then you can run it and it will automatically delete the file. I guess I misspelled, no, that's fine. Okay, so one other thing that might be useful actually is let's add a task to run Valgrind on our program. So let's copy this command we had previously. This is just an example of how make can be really useful to you. So we'll make this dependent on the scratch task, and we'll make it run the Valgrind command with the executable name // and just for posterity's sake, we'll just have it deleted as well. So it'll leak check your program and then it'll remove it. Okay. So let's see if this works. Make, what did I call this? We're not going to call this scratch. We're going to call this LC for leak check. So we can do make LC, and it's going to run Valgrind. And you can see, like, yay, we don't have any leak checks. Okay. So again, make is going to be a program that's already installed on Tux. So if you have a Makefile, I would recommend just copying this one. It's fine. And again, just replace your program name, replace scratch with your program name. And then when you're in the current directory of your program, you can type make to generate the executable, scratch. You can type make run to run it and automatically remove it. You can type make LC to leak check it. Interesting that it didn't. Odd. Oh well. Maybe it needed to make it first in the first task, and then it didn't have it for the what it needed later. That's funny. Oh well. You can see it first compiled the program, and then it ran Valgrind with the executable. But yeah, Makefiles, super useful. You should make use of them and make use of the tool Valgrind to troubleshoot your leak checks as well. But yeah, I think that's it for this video. Thank you for your time, guys. See you later.